Welcome to my channel. In this video, we evaluate these integrals using U-Sub. These are U-Sub integrations. So let's tackle the first one. First one, integral of x over x squared plus 1 dx. So this is a U-Sub. And the trick here is to let u be equal to the denominator, which is x squared plus 1. Take the derivative of u with respect to x, and that should be equal to 2x. Multiply both sides by dx. We have du to be equal to 2x dx. Can isolate dx by dividing by 2x, and that should be dx being equal to du over 2x. So that implies that wherever we see dx in our integral, we plug in du over 2x. Now let's take everything from the x world into the u world and see how it looks. So integral of x over x squared plus 1 dx now looks like integral of x. I'm leaving the x for now for obvious reasons. All over x squared plus 1. X squared plus 1 is u, which is u, times dx. Dx is du over 2x. That is from here, from our U-Sub. So this integral becomes x cancels x, we are left with 1 over u times du over 2. 1/2 is a constant, so 1/2 comes in front of the integral. 1/2 integral of 1 over u du. This now looks integrable. So integral of 1 over u is just a natural logarithm of u. So that is 1/2 natural logarithm of u plus constant c. But we are not done. We need to move from the u world into the x world. The original integral was in terms of x. Our final answer must be in terms of x. So we have to plug back u. So we must find u in terms of x. But u in terms of x, u was already x squared plus 1 in our U-Sub. So you can just plug that in. So that becomes 1/2 natural logarithm of x squared plus 1 plus constant c. So this integral, the first integral, the answer for that integral is 1/2 natural logarithm of x squared plus 1 plus a constant of integration, because we are dealing with indefinite integrals. We do not need to put this one in absolute value terms, because x squared plus 1 is always a positive number regardless of the value of x. So this is always a positive number, plus 1. This is a positive number. So we don't need to put it in absolute value terms. So let's look at the second question. The second question, we are going to evaluate the integral of 1 divided by square root of 1 minus x squared dx. So with this, we can use another U-Sub, but this is a different kind of U-Sub. This is what we call the trig sub. So we can let x to be equal to sine of theta. So it means wherever we see x, we are going to put in sine of theta. What about dx? We do not have the value for dx in terms of theta, so we can do that by differentiating dx. The theta should be equal to cosine theta, because when you differentiate sine theta, you are going to get cosine theta. So you multiply both sides by the theta, that should be equal to dx should be equal to cosine theta d theta. So we have gotten our expression for x, which is sine theta. We have gotten an expression for dx, which is cosine theta d theta. So we are now going to move from the x world into the theta world. So we have the integral of 1 over the square root of 1 minus x squared dx should be equal to integral of 1 over square root of 1 minus x squared, but x is sine theta, so that should be sine theta squared d theta. Dx is cosine theta d theta. So this becomes integral of 1 all over the square root of 1 minus sine squared theta. All this in the square root times cosine theta d theta. We already know from our trig identities, which I proved in my previous video. We know that sine squared theta plus cosine squared theta is equals to 1. This is the Pythagorean theorem. So with this, we can find 1 minus sine squared theta. So cosine squared theta is equals to 1 minus sine squared theta. So it means in place of 1 minus sine squared theta, we can plug in cosine squared theta in here. So our integral becomes, continue from here, integral of 1 all over the square root of 1 minus x squared dx now can be evaluated as integral of 1 all over the square root of 1. So 1 minus sine squared theta is cosine squared theta times cosine theta d theta, and that evaluates to integral of 1 all over cosine squared theta in a square root. The square cancels the square root, and that becomes only cosine theta, and we have cosine theta d theta. So in the end, we are just integrating the theta. That is just like integrating 1 in the theta world, and that should be equal to just theta plus c. But the original integral was in terms of x here, but our answer is in terms of theta. So it means we have to move away from theta world into the x world, and we can do that by recognizing that x was equal to sine theta. So in order to find theta in terms of x, you can just use this expression here. So we know that x was equal to sine theta. So in that case, we can find theta in terms of x. So here, sine inverse of x should be equal to theta. So it means in place of theta, we are going to put in sine inverse of x, and that will be the value of the second integral. Now let's wrap it up here. So integral of 1 all over the square root of 1 minus x squared dx is equals to sine inverse of x plus c, or the arcsine of x plus c. That is the value of this integral. Remember in my previous video where I proved the derivative of the sine inverse of x, we established that the derivative of the sine inverse of x, or the arcsine of x, is equals to 1 all over the square root of 1 minus x squared. Taking the integral of this one, which is the antiderivative of this one, we are getting back to the sine inverse of x. So that is how it works. Now the last one, let me go up and see what it was. Okay, this is an exponential function, but it's also integration by parts. So the third one, integral of x e to the x squared dx. So this is also u sub. So we can let u to be equal to x squared. Next, du dx is equals to 2x. You multiply both sides by dx, you are going to have du is equal to 2x dx. So I just want to divide here by 2, divide here by 2. I want to leave x dx to be equal to just du over 2, because I need that expression here. So the integral of x e to the x squared dx, I can also write this one as integral of e to the x squared times x dx. So this one becomes integral of e to the x squared. X squared is u, that is from our u sub, so we just plug in u, times x dx. X dx is du over 2, that is just du over 2, and everything simplifies out nicely. So 1/2 is a constant, has nothing to do with u, comes in front. Integral of e to the u du. This is an exponential function. Integral of e to the u is just e to the u, nothing changes. So that is 1/2 e to the u plus c, and you are done. You are not done. You have to move from the u world back into the x world. Our original integral is in terms of x. Our final answer is in terms of u. So it means we are not done. We have to plug back what u is in terms of x so that we can get our answer in terms of x, like what we did for the rest. So we know that u is equal to x squared. That is from our u sub. So we can just plug that back in here, and we have our integral x e to the x squared dx is equals to 1/2 e to the x squared plus c. And that is the value of this third integral. So this is how the u sub works. So the first one being a natural logarithmic function, the second one being a trig function, and the last one being an exponential function. So that's it. Thank you for watching the video. You may like this video, subscribe to my channel, and I will see you in the next video. Thank you.